Hello, this is Garrett Keane, and this is the fourth video in the series of videos for the solution of a traverse problem. It's the traverse problem from the 2014 paper, and it's shown here. In the first video we got the horizontal distances between the stations, given slope distances and zenith angle. On the second video we looked at getting the angular misclosure of the survey and adjusting the angles. In the third video we looked at transferring these values across to our form, which we have to fill in for the traverse solution. We have our angles here, A, B, C and D. We have our first whole circle bearing, and we have the horizontal distances in here, and finally we have the initial coordinate of the first point A, the easting and the northing. So I have a couple of illustrations. I'm just going to paste them in here. And these should help us in working out the next thing, which is the whole circle bearings. Part 3 in the question, the forward whole circle bearing of each line. So if I come to the spreadsheet, I've copied out a few things from your notes here. And the first definition is the forward bearing of any line is equal to the back bearing of the previous line and the clockwise angle plus the clockwise angle between the lines. So if we look at this forward bearing, we've been given the forward bearing from A to D is 193 degrees, 10 minutes and 12 seconds. Now if that's the forward bearing from A to D, it is also the backward bearing from D to A. And if we're going in an anti-clockwise direction in our traverse, this is in effect the backward bearing of the previous line, D to A, if we're considering that we're looking for the forward bearing from A to B. So if we follow our rule, we know the back bearing of the previous line, which is D to A, is 193, 10, 12. We know the internal angle is 87.0550. So what you need to do is add these two together to get the forward bearing A to B. Now you can see I already have it done here, so if I just do control, if I just reveal it, you can see I've added the two of them together, and they're 280 degrees, 15 minutes and 58 seconds. So that is the forward bearing from A to B relative to this north direction here. It's the clockwise angle relative to that north direction. The next thing we need to do is to obtain the backward bearing B back to A. And basically the rule is, if the forward bearing is less than 180, we add 180 to it, to the forward bearing, to get the backward bearing. Or if in this case the forward bearing is greater than 180, we subtract 180 from it to get the backward bearing. So if we subtract 180 from this, I'll just show it here, it's obviously 100 degrees, 15 minutes and 58 seconds. And you can see that that is the clockwise angle. If I bring this north vector down here and just draw it in here at the tail at B, at station B, you can see the angle here is slightly greater than 90 degrees, and it makes sense that that clockwise angle measured from that north direction is 100 degrees, 15 minutes and 58 seconds. The next thing, having got that, is we now need the forward bearing of the next line, which is B to C. Now B to C is, we follow our rule, the forward bearing of any line is the back bearing of the previous line. So the back bearing of the previous line is B to A, which is 100 degrees, 15 minutes, 58 seconds, plus the clockwise angle between the lines, and that's given here. It's this angle in here. The corrected angle is 111 degrees, 48 minutes and 12 seconds. So basically, to get the forward bearing of B of the next line, we add the two previous lines values together. So I'll give you a second to do that. You can press the pause button and add the two of them together. I'm about to reveal the result now. And you can see when you add those two together, you get 212 degrees, 4 minutes and 10 seconds. So I actually have it done down here. You can see here, if I just bring this north vector down here, put the tail of it at station B and draw the angle around here, you can see it's greater than a horizontal line, 180 degrees, and you can see that 212 degrees is a reasonable value for that. The next thing we have to do is get the backward bearing. That's if you're standing at station C and looking back towards B, what is the angle relative to the north direction? So let's look at our rule. To obtain the back bearing from the forward bearing, if the forward bearing is greater than 180, we'll take the second rule because it is greater than 180, we subtract 180 from it to get the backward bearing. So basically following that rule we subtract 180 from the 212 here. Okay, I'll give you a second to do that, and if you want to pause it and do it, I'm about to reveal the answer now. It's 32 degrees, 4 minutes and 10 seconds. So now we need you can see that's shown in here, and it's a reasonable value. You can see graphically it's a reasonable value. The clockwise angle from this north direction is approximately 32 degrees, 4 minutes and 10 seconds. The next thing we're looking for is this forward whole circle bearing with this line here. If you look at the north direction here, you can see I have the value worked out. And the rule is as follows. The forward bearing of any line is the back bearing of the previous line, which is the 32 degrees, 4 minutes and 10 seconds, plus the clockwise angle between them. So I basically have to add on this angle in here. So you add these two together. So I'll just reveal that out by just adding these two together. We get 129 degrees, 52 minutes and 5 seconds. So you see it drawn in here. The clockwise angle is shown. Then we need to get the backward angle. The backward bearing of the same line. So that's if we move to D and look back towards C, what's the angle, clockwise angle relative to this north direction? We come to a rule. If the forward bearing is less than 180, we add 180 to it to get the backward bearing. Our forward bearing here is less than 180, therefore we have to add 180 onto it. So you can try it there quickly yourself, and I'll just reveal it. It's 309 degrees, 52 minutes and 5 seconds. So same again, we need the forward bearing from D to A. So the forward bearing of any line is the back bearing of the previous line. That's the 309, 52, 5. The back bearing of the line CD, in other words, plus the clockwise angle between them. That's given in here. The correct version is here. So we add these two together again. Now remember, when you add these two together, it's 309 and 63. So you can see you're going to go above 360 there. So you add the two of them together, but if they go above 360, you then take away 360 from the answer. So you can see it's adding up to 373 degrees, 10 minutes and 12 seconds. So we have to subtract 360 from it because we've gone full circle. And you can see I've shown the angle in here, 13 degrees, 10 minutes and 12 seconds. And then the last thing we need is the backward whole circle bearing for that line. And I'll just reveal that. It's basically, once again, if the bearing is less than 180, which it is, we add 180 to it. And you can see here, that's 193, and that's actually our the value that we started with up here. This, in effect, is the backward bearing of this line, A to D to A. Okay, thank you. And before I continue, I'll just move it off to the side here. And what we have to do is transfer these values across. So this 280, 50 and 58, you just transfer it into this cell here. So I'll do that there. Likewise, we transferred the forward bearing BC into these cells here. And I also for C to D and for D to A. So what we essentially have for each line here is a set of polar coordinates. For this line here, we have an angle at the start of the line relative to a fixed reference at the north here, and we have a distance shown here is 112,635. So we have a set of polar coordinates for that line there. Likewise, we have the same down here for the second line, B to C. The forward whole circle bearing is 212 degrees, 4 minutes and 10 seconds, and the length of the line is 106.264. Likewise, for the third line, C to D, we have our forward whole circle bearing, 129 degrees, 52 minutes and 5 seconds, and the length of the line is 164,605. And if I just pull this one down for the last line, we have a forward whole circle bearing of 13 degrees, 10 minutes and 12 seconds, and the length of the line is 180.31. So we have worked out the whole circle bearing and the length, and basically the polar coordinates for each of the 4 lines. And we will then use those in the next video. We'll show how we'll work out our partial coordinates using those values. Okay, thank you very much for listening.